Hello, this is Nitin Dahad with EE Times. I'm here at HiPEAC 2026 conference and with a company called
PolyMage Labs. Yeah.
PolyMage Labs. And I'm here with Uday Bondhugula, who's the founder. Uday, hello, how are you?
Hi Nitin, I'm fine, thank you. Yeah.
Okay, tell us what's the company do?
So PolyMage Labs is a AI compiler startup. It basically means we build compiler systems for AI chips, the new AI chips that are coming out, and for the popular AI programming frameworks like PyTorch and JAX. So the software challenge is huge here, and PolyMage Labs is building products that make it easier to build new compilers for new chips.
That sounds very easy, but there's a lot that's gone into that. You've just done a deal with Tenstorrent, which you announced in January 2026. But before we go there, just tell us a little bit about the work and the journey that's gone into this.
Okay, great. So I'm a professor in computer science at the Indian Institute of Science, and I've been working in high-performance computing and compilers for the AI domain for the past 5 to 6 years. And the technology that's required here is quite deep, and it's based on my research over the last 10 or 15 years. Around 2019, when the problem became quite evident that there's so many AI chips sort of coming out, and these frameworks, which are so high level and very productive frameworks, the difference in abstraction between what these frameworks provide and what the hardware supports is huge. And so as a result, there was clearly a lot of vacuum here in basically trying to figure out how to build the software stack to power these chips, to exploit these chips from these frameworks. And that's when I realized I should start a company that solves this problem.
And now, when you say problem, the problem is what just now? Currently, what's the way people would do it normally?
So the way people do it normally is they spend a lot of time writing libraries by hand, kernels and libraries by hand, which is quite painstaking, takes a lot of time, and it has to be repeated each time there's a new generation of hardware with the changes to the chip. So we really need some automatic infrastructure that can basically generate code, right? So that you don't have to sort of rely on human programmers to basically support these frameworks.
So your USP is that infrastructure you've built. What is that exactly? And it runs locally, doesn't it? Just give us an idea of the scale of that and how easily sort of deployed it is.
Right, so that infrastructure is called polyblocks. So as it says, it's blocks, which means it is not the compiler itself, but it's infrastructure with which you can build a new compiler. It can support multiple frameworks, so we don't redo everything. Each time there's a new framework or there's a new chip, we reuse these building blocks, put them together in different ways, so that you get you get high-performant code over here. And in that sense, the compiler runs locally. You can generate code, and then later on you can deploy that, or you can do what is called just-in-time compilation to support these frameworks.
And what kind of savings in time or cost are we talking about?
So I think this is pretty important. So we always hear AI requires a lot of energy, big data centers, and so it's absolutely important. If you're able to take the same model and then you're able to run it much faster, then it directly translates to savings in energy and power. So with good compilers, you can actually run the same model potentially 2 times, 3 times, or even 4 times faster without changing the results, right? So the semantics of the program remain the same, but you've just found a clever way to execute it faster, and that's what compilers deliver through advanced transformations.
And you've got, you signed this deal with Tenstorrent. Tell us what that involves and why it's important for you.
Absolutely. So Tenstorrent is building some exciting new AI hardware, which is very unique, and over here, their hardware is also very amenable to compiler optimization, and so basically there are many chips which are very hard to generate code for example, but Tenstorrent we felt they've got it right in terms of building the lower layers of their software stack such that compilers can be efficient and can generate good code, and so we partnered with them to build a polyblocks based compiler stack for Tenstorrent, and within 3 to 6 months, we built a very performant compiler which could do advanced transformation, something that takes normally 3 to 6 years.
Wow. Okay.
Yeah.
So that really is the reason why they said, okay, we'll work with you.
Absolutely, right. So Polyblocks had all the basically techniques and capabilities to quickly build a compiler for their hardware that could go straight from PyTorch to basically their chips.
And you have a chart here that shows part of how that works, yeah?
Yeah.
Yeah.
So I think this going a little bit more detail into how our compiler infrastructure is built. So you have these frameworks on this side and hardware over here, and basically putting together a good compiler basically means you have techniques to do important transformations like fusion across operators, tiling, and and you can map to the various units on your hardware. And so here I have basically logos of various vendors we support: NVIDIA GPUs, AMD GPUs, CPUs, and here's the Tenstorrent one where we were able to use the Polyblocks engine to compile PyTorch for their hardware and got some really interesting results in terms of performance.
And what's your business model?
So we are not restricted to one hardware. Polyblocks can be non-exclusively licensed to various AI chip vendors who are interested in compilers. So basically, we execute a proof of concept. We execute an engagement to build a proof of concept compiler, which takes 3 to 6 months, and we'll show them, look, it's possible to get a good compiler. And after that, there's a license fee, like a one-time license fee to basically non-exclusively license Polyblocks compiler with sources so that they can build derivatives and subsequently services around it, which is to continue to support basically the software and update it and so on.
So, and you're, I think, 9 people at the moment?
Right now we are a team of 9 compiler engineers, including me. And it took us about 3 to 4 years to build this infrastructure, and now we can say that we can very quickly and confidently build a new compiler for a chip.
So,
right? Yeah.
So what's your roadmap? What's next? I mean, in terms of what you're doing, either the business or iterations on this.
Yeah. So at this point, we are basically trying to find more customers, basically scaling this up. We have a Tenstorrent, similarly other vendors in this space who are building, whether it's data center level cards or edge devices, to basically speed up AI inference, do AI inference sort of more efficiently. So we would like to engage with them and build Polyblocks-based compiler stack. That's one direction, sort of more customers. Also, we are right now a high-performance compiler systems, AI compiler systems company. We're also looking at sort of moving towards becoming a high-performance AI systems company, in the sense not just do the compiler, but take the application, optimize it with Polyblocks, and basically show the application as showcase the application as something that's been enabled because of high-performance compiler technology.
Now, from what our conversation earlier, I think you said this is quite groundbreaking in that the industry is still doing it in a very conventional way. What do you think is going to be the impact of what you're doing on the industry?
Clearly, at this point, most hardware vendors are struggling to compete with NVIDIA because they do not have the kind of stable ecosystem that NVIDIA has developed over the last 15, 20, 25 years. Right? And it's going to take a lot of time for the new chip vendors to basically do that. But Polyblocks provides you a way to basically go fast forward and and sort of enter this space and sort of hit the ground running and have people use their hardware, because it's just so much more easier to program when you have a compiler like this. And as a result, so that's the impact we're going to have. There will be a diversity of hardware which can run various AI models efficiently. And Polyblocks will enable that because you have this programming support.
I think in the keynote this morning we heard about silicon diversity, so that's kind of addressing that kind of issue as well, I guess.
Absolutely, right. So there are different kinds of models that cater to different domains, and different kinds of AI chips are going to be specialized in different ways to run specific things, and so you really need a robust software ecosystem, and that has been missing outside of NVIDIA and AMD. That's been missing, and I think we feel we could bridge that gap. Right? Yeah.
Well, Uday, good luck with that, and thank you for speaking to us.
Yeah, thank you very much, Nitin. Yeah, bye.